Hey YouTube, Rob here from Helly Skunk Works, and today I would like to demonstrate a product that was sent to me by the good people over at depace.net. It is a vector network analyzer slash antenna analyzer, and the unit was sent to me about 2 weeks ago, and I've had some time to use the unit. For those of you who are not familiar with what a unit like this does, it's pretty much all about being able to both design, construct, tweak, and tune not only antennas but also frequency reactive components. By that I mean testing the bandwidth and characteristics of things like small amplifiers, such as this one. This is a BNC mounted amplifier which has a BNC mount for an antenna. Filters for antennas, band pass filters or notch filters. We can test the characteristics of those. And for antennas, such as these, small or large, we can test the VSWR. We can look at the return loss of an antenna. We can also Smith chart it. For those of you who may not be familiar with what that is, we'll be getting into that in a later video, but for right now I just want to demonstrate the basic functions of the KC901S vector network analyzer. So the obvious question is, well, what does this thing do? How is it relevant to RC, FPV, first person view flying, and so on and so forth? Well, to do first person view flying, we have to use such things as transmitters, receivers, and antennas. And particularly if you're operating in the VHF, UHF, such as the 400 band or 900 megahertz band, 1.2 gigs, 1.2 gigahertz, or 2.4, this would be especially helpful. Anything that falls within that region we can do. Now, to give a practical example of this, I want to first start out by just demonstrating something. These two antennas, some years back I had bought a 900 megahertz FPV system, and it was pretty much like a ready-made package. It had the camera, the transmitter, the receiver, and also the antenna. Now, the antenna that came with it was this one here. Let's see if I can get a little more focused. And that's the small antenna that came with the transmitter. But later on down the road I ended up buying this antenna. The transmit frequency for the transmitter was 920 megahertz. So this is the one, this is the first one that came with the transmitter that I was using for quite a while, and the results were just kind of so-so to maybe not so great. Bought this antenna and it worked a lot better. I was getting, I would say, almost, maybe not quite twice the range, but almost. So how is the KC901S analyzer useful to tell us what's going on? Okay, well, here's what we can do. What we're going to do is we're going to take the first antenna and we're going to look at its characteristics for the frequency that we're interested in. In this case, it would be 920 megahertz. And we're going to check the reflection of the antenna, in other words, the VSWR, the voltage standing wave ratio at that frequency. So what I can do is, this is what's called our reflection test port, also known as a S11 or S11. We'll get into that also later. But I'm just simply going to screw this onto the port like so. I'll give you a better look at this with the little GoPro camera that's filming here. I screwed it on. Okay, there we go. Okay, now what I'm going to do is I'm going to hit the mode switch on the VNA, and we will select over here to the far right, or excuse me, the far left function button is S11, or reflection test. We'll go ahead and press that button, and we'll go ahead and hit run. Now that's going to be running the test. Now right now the frequency is not exactly where we want it. It's at around 900 megahertz is the center frequency. So what I'm going to do is I'm going to change the center frequency to 920. So I'll hit center, and I'll go ahead and enter 920. That would be megahertz. I hit enter. And now what I'm going to do is I have a span of about 280, and I'm going to change the span to, there's a preset in here. You can change it to whatever you want, as wide or as narrow as you want, but I'm going to change it to 500. Just like that. And what we can see here, if you read that top part of that display, and I'm going to zoom in with the other camera here, so I want you to be able to have a good look at this. Those numbers right up there are indicating the frequency for that first marker, the little red dot. That thing will stay still. There we go. And as I scroll over, oh, there we go. I can put that right at the center, which is at 920 megahertz right there. So basically we can see, let's back on again a bit. We can see, judging by where the first red marker is right there, that's at the center, that's 920 megahertz. We can see that our SWR, reading it from the top there, is about 3.7 to 1, which is not very good at that frequency. Okay, so what do we do about that? Well, here's where we can very clearly see and distinguish the difference between the two antennas. So I'll go ahead and I'll take this one off. Let's get a shot of this. And you can see that the SWR has gone back to infinite essentially. We're going to take the other antenna. I'm going to screw it on. And now, as you look at the display, you can see where that SWR is for this other antenna, which is below, well, it's right about 1.16 to 1. So that's significantly lower. That's very low reflection. So obviously, for the frequency that we want to operate at, which would be 920 megahertz with that particular transmitter, this antenna is going to be transmitting a lot better. And by the way, you can notice just how sensitive antennas, particularly small antennas that are on small devices, can be, because as you look, as I move my hand, look how much it changes that curve just by moving my hand around it. Look there, I put my hand there, it's way off frequency. So that's why sometimes if we tune or design our antennas on the bench and we don't really have any way to test them, we might think that they're resonant or they have a good standing wave ratio at one particular frequency, but once we put it on the aircraft and attach it to the transmitter, it might not be so good. Whereas with this, we can actually measure it in real time once it is attached to the aircraft, we have a small coax or something like that. We attach it to that and measure the antenna. So that's being able to. Now, this is something we're not going to get into much in depth right now. We will later on. But there are different formats to this. You can see there the button. Let's see if we can get a good focus. Whoops, get a good focus on that. Anyway, the button that I'm pressing is called Format, and we can either read the phase angle, return loss, VSWR, Smith chart, or impedance. So for some of you, this might be a little technical if you don't know a whole lot about it right now. Some of you will know what it is, but for example, this is our phase of the antenna based on the frequency, the wavelength, and so on and so forth. Go back to Format, we look at return loss. This is another type of way of showing SWR. It's just indicating a different value, different type of test. Anyway, Format again we go back to the straight VSWR mode. That's showing what our voltage standing wave ratio is. And here's what's really nice about this. Well, first I'll do impedance. This is basically showing the impedance of our antenna at that frequency. Again, let me make sure this is on 920. Alright, so we can see right there that our impedance is approximately 58 ohms. How is that useful? Well, if the output impedance of our transmitter is 50 ohms, which is pretty much standard for almost all sort or every sort of RF transmitter these days. Well, we know now that our impedance of this antenna and at that frequency is 58 ohm. And as we go down the line, obviously we can see that that impedance is changing with frequency. So, but here's something that's really nice about this analyzer, and this is particularly useful when it comes to designing your own antennas from scratch, because you need to know and understand the impedance of the antenna. And the way that we look at things like that in RF engineering is with something called the Smith chart. So I'll go to Format, I'll hit Smith chart. Now right now this is probably for a lot of people, I don't expect them to understand this. Let me zoom out just a bit here. There we go. Bring that in. Yeah, I don't expect everybody to understand this right now. But essentially what this round graph is showing us is it's showing us the relationship of frequency to resonance to impedance. And again, now watch as I move my hand. See how the characteristics of the antenna will change? I'm not even going to try to explain the Smith chart right now. What I will say is that if you really want to learn more about this, because it's such a useful tool, particularly for if you want to do antenna design, it's really all about impedance matching, which is a very big part of antenna design and other things in RF engineering. But I believe there's a website, I think it's called Antenna Theory or Antenna-Theory. I don't know if it's .com or .org. But if you look up that website and then you look up Smith chart, they have some really extensive and pretty good tutorials on how Smith charts work, and you know, how you use them, how you go about doing the calculations to match one impedance to another, and so on and so forth. So I would, if you want to learn more about Smith charts, I would definitely recommend that website. Anyway, for right now, I wanted to show you how the KC901S works for looking at reflection, the reflection test, or again, what's called the S11 test. And also, let's just suppose for a moment that, take this off of here again. Let's suppose that you have an antenna where you really don't know. It's actually a fairly popular antenna for wideband receivers. It's called the Watson. It's the, what is it, the 889, I believe. Yeah, Watson 889, and it's a telescoping antenna, so it can get longer or shorter. And this is where it really gets interesting to look at something like this. Put my adapter on. This is a female BNC to SMA adapter. I'll attach it to the unit. And what I'm going to do is, once this is attached, let me stop it for right now. I'm going to attach the unit. Attach the antenna to the unit. I'm going to set my center frequency to 1500 megahertz, which would be the center. And I'm going to set my span to full span. So we're seeing everything from 100 kilohertz all the way up to 3 gigahertz. And I'm going to hit run and check that out. So you can see that this antenna, and it's at its shortest length right now. Let's show you this with the other camera. Right now it's at its shortest length up here. And you can see from the display there's multiple dips on this, which means that it's essentially resonant at these multiple points. As I pull the antenna out a little bit, little by little, you'll see that change each time. Actually, what I can do is I can put a hold, use this button right here on the left. It's a function button that says hold. I can hold that. Now as I change the length of the antenna, the blue line is the held line. So that's the one that's holding, and the yellow one is how it's changing. So see, as I lengthen it more and more, you can see how the characteristics of this antenna is changing. And this is absolutely just an invaluable tool for, I mean, particularly anything to do with antennas. And they don't have to be small antennas. They can be small, they can be large. Where it comes to radio controlled aircraft and FPV, you can design antennas, you can match your antennas, you can tweak them. I'm going to pull this out all the way, and you can see how those characteristics really change. And the unit is showing this, that exactly. We have a visual representation of exactly how it's changing, and that's extremely useful for design, or just simply checking your antennas to see what's going on. Because as most of you probably know, if you have a high VSWR at the frequency that you're operating at, your transmitter, let's suppose that your transmitter has an output of, we'll just say 1000 milliwatts. But let's say that your SWR is 3 to 1. Well, a 3 to 1 SWR means a 25% power reflection. So in other words, your transmitter is sending 1000 milliwatts to the antenna. However, 1/4 of that, or 250 milliwatts worth of that, is simply being reflected back into the transmitter, where it has to be, basically it's being absorbed by the transmitter and re-radiated simply as heat, but that's a loss. So your effective output is only 750 milliwatts. And it just gets worse the higher your SWR goes. So you can see how that would be very helpful to know, because that will severely It'll cut down your range quite a bit, and obviously it's not good for your transmitter if your transmitter is higher power, and so on and so forth. So that's pretty much it. Now this is just an introductory video to this. We will be doing some more. We're going to go through pretty much every aspect of this vector network analyzer, antenna analyzer, and in our upcoming videos I will show you how you can take things like, this is a small, again, inline amplifier. This here, which is often very important in RC FPV work. This is a bandpass filter. You have your bandpass filters, and they allow a certain frequency or frequency band to pass, and then you have notch filters or stop filters which stop certain frequencies, and these can be very important to attach between your antennas and your transmitters or receivers to block out, to either pass certain frequencies that you want to pass or to block out frequencies that you do not want to pass. A very common example of that is if you're using a dual frequency system. Say that your control link is on 1.2 gigahertz and your video link is on 2.4. Well, without getting too into it right now, too technical, you don't want the high power, say, of your transmitter output getting into your control signal feed, and so on and so forth. So that's where things like filters can come in extremely handy. Anyway, that's pretty much just like an initial introduction to this unit. Again, the unit, it's designed by the people. It's called deepace.net, DEEPACE.net, and they are RF engineers. They design their own stuff from the ground up. They designed this. It's not a clone or copy of anything. I would probably say, if anything, people copy or clone their stuff. But definitely check it out. If you're serious about wanting to check out your stuff, your FPV stuff, your antennas, impedance matching, give it a look. It's a great unit. So with that, we'll get ready to end this video. There will be more upcoming. We'll go through and cover a lot more. Be kind of like a mini class on how to design antennas, match antennas, check antennas, and for various frequencies, quarter wave antennas, say like a quarter wave monopole or a half wave dipole, and which ones work the best, which ones are more efficient, and why. And we'll look at the results on the analyzer as we design the antenna, and should learn a lot of great stuff. So again, that's from the guys over at deepace.net. Check it out, and that's pretty much it. Everybody, thanks for watching. If you like the video, hit the like, hit the subscribe, and I will talk to you next time.